so you've decided to do quantitative analysis. Congratulations. Now you have to choose a method. You have a lot of options when it comes to quantitative data and all of the different stats you can do with it. This video is going to let you know, hopefully a priori, what you should choose, but if not, this will also allow you to say, hey, I have a lot of data and I don't know what to do with it, and you will also be able to choose the correct analysis. So before we start, we really have to understand the types of data that you can get, that you can gather. So you can get categorical information or continuous. There are more than these, but these are just the general ones that we're going to kind of focus on. So for categorical information, it can be nominal or ordinal. Nominal means there is no order to these categories. We might assign them numbers, but we could assign them any number that we wanted to. There's no order. Ordinal are still categories, but there is now a rank order. So the categories do have an order to them. So if we label them 1 through 6, 6 is higher than 1. On the flip side, we have continuous data, continuous variables. These are what we consider our numeric information. These are interval. They should be equal intervals between them. And they can also be considered ratio. And all ratio means is that it's an equal interval where we actually have a 0 that means something. That might be important, that might not be important. Most of the time, we're just happy that it's interval. So here's some examples. With nominal, this could be just race and ethnicity. It doesn't matter what order we put the categories in, even though we might label them 1 through 5 or 7 or 11, whichever census you're using. Ordinal would be something like income bracket, not actual income, but income bracket. So you give them a range that they have checked in the survey of I'm in the income bracket of $40,000 to $50,000 a year. That is more than the bracket of $20,000 to $30,000 a year. So it's still a category. We don't know how many people are $49,000 versus $41,000. We just know that they're in this range. That makes it ordinal. If we ask actual income, where they typed in a number, that becomes continuous information. So there is an order to the money. For example, the distance between $1 and $2 is the exact same distance between $3 and $4. Or think of it as time. So the distance between 1 and 2 minutes is the exact same distance between 5 and 6 minutes. So, or these are rulers. So if you think of an actual ruler, 1 inch is the same. It doesn't matter where on the ruler you are. 1 inch represents 1 inch. That is what an interval should be. This can be a quiz score. So the distance between amount of points that you get is the same throughout. And percents would also fall into this range as well. If you are using a survey that is a Likert scale, this gets a little bit confusing. So if we are using a 1 to 4 Likert scale of strongly disagree, disagree, agree, and strongly agree, that is technically ordinal information. We don't really know the distance between agree and strongly disagree, and if that's the same distance throughout all 4 categories. But most of the time, we actually treat that as continuous information. You can kind of choose. If you want to actually go from ordinal to interval, you use Roche analysis or item response theory. Not included in this video. So there's 2 general purposes of stats. If you just want to describe your data set, that's descriptives. If you want to infer from your data set to a population, so if you take a sample and you want to infer it to a larger group, that's when we're going to use inferential statistics. And this is really important because it matters what analysis we're actually using. P.S. If you're using inferential statistics, you're doing descriptives first. So with descriptive statistics, we have 3 basic concepts. Measuring center, so that's central tendency. So we have all of this data, we kind of throw it all on a map. Where is center? What is the best number to measure center? Mean, median, or mode. You've probably heard of those. Mean is our gold standard, median is used when we have skewed data, and mode is used when we have categorical information. Variability now says, since we have center, how varied, how spread out is our data? Variance and standard deviation, if we have one, we have the other. Standard deviation is kind of the gold standard. And range isn't really helpful unless you have categories, and then even then, it's kind of not used. We can also, within descriptive statistics, look at relative standing. This is done a lot in education. So we have this data, we can pull out one score and see where they fall compared to everyone else. Percentile ranks, for example, if you're in the 90th percentile, you are above 90% of the data. Inferential statistics, we're going to start with some stats language. If you want to use the word difference, then you need one continuous variable and you need one categorical variable. If you want to use the word association, you're going to use two categorical variables. Or you can also have a standard or goal or expectation, which is used in a lot of the higher level stats. If you want to use the word relationship or prediction, you're going to need two continuous variables. So we have our three choices. I'm going to start over here with relationships. If you want to use the word relationship, we're going to do a correlation. If we want to try to predict that relationship, then we're going to use simple regression or multiple regression, or some multivariate technique. In the middle, if we want to use the word association, we have categorical information. We can do a chi-square test of association. This is also called a crosstab. Or you can do a goodness of fit. Again, this is typically used when you have a standard or expectation, and we use this for a lot of the higher level stats models. You'll see it there. Difference testing is a little bit more complicated. Not complicated, but there's a lot more options. So with the difference test, we will have one categorical and one continuous variable. So let me show you what some of the options look like. It comes down to how many groups, or called samples, do you want to look at. If you want to look at how your sample compares to the population, that's going to be a one sample test of differences. We can do z-test, a t-test, or a proportion, depending on what information you actually gather. If you want to do two groups, so we have two separate groups. It says two samples, but we can sample them all together and then split them into groups. This is going to come down to, is it a dependent test, or is it pre-post, or the same people in both groups? That's dependent. Or is it independent, where the people are different? So male and female would be two groups. You can't be in both groups. You have to pick one. We can also do this with proportion. This is used a lot in elections. How many out of how many? If we have more than two groups, so right now we can only do male and female. We could do minority or not minority. If we wanted to split by all of the different race and ethnicities, then we would need a 3 sample or 3 groups. Here we're going to use ANOVA. We can do a one-way ANOVA, we can do a factorial ANOVA, depending on how many variables we want to include. So now that we know what test that we need, you can go to the next part and look for resources on how to actually conduct those tests.